So far we have implemented this step here. So we have booking service that puts messages on a topic in Kafka, and now we want a consumer of these messages, so we want to create order service. So in the next step we'll see how to create a consumer of these messages we've been putting on this Kafka topic, and I will show you how to do that in order service. So let's go on Spring Initializer and let's create a new project. It will be the same as the other ones. We'll be using Java with Maven, Spring Boot version 3.4.2 and Java 21. We need to add some dependencies, so let's add Spring Web, Lombok, Apache Kafka, as we're going to be the consumers, and we need to add MySQL, Dryware, and Spring JPA. This is all we need, so let's generate and let's open this in IntelliJ. So here is what we have. This is going to be simpler than the other two microservices. So the first thing we need to do is to create a service class. We are not going to have any controller here, as order service is going to be picking up messages from Kafka topic. So let's create a service package, and in here let's create an order service class. Let's tag it as a service class, and we also want to add logging, so let's add SLF4J. Because this is going to be a consumer, we are going to be using Kafka tags to do that. So you want to do @Kafka, and it's called Kafka listener. We want to give it a topic name and a group ID. So this topic has to be the same one as the one we chose on booking service. This is the topic where booking service puts the messages, and it's the same topic we want to listen messages on. And this will be a public void, and we'll call it order event. Here we're going to be taking in a booking event. So we need to be a bit careful here. I'll show you what I mean with that. So let's call it booking event. And let's add some logs. So log.info received order booking event. So let's add that to the log. And now the next steps are, we want to create an order object for the database. So we want to save this order to our MySQL DB. And the next thing we want to do is to update our inventory. So these are the two main steps in here. This booking event needs to be the same object that we're sending in the booking service. Let me show you what I mean. If you open the booking event, this booking event is at this specific path, and that's the same one we want in order service as well. One of the options is to go into the pom.xml of booking service and create a jar and then import this as a dependency in order service. But the easiest way we are going to do for this video is we are going to recreate this tree directory with the same class inside booking service. So com.example.LeetJourney.bookingservice.event and the booking event class inside. And that's the one that our order service, our consumer, is going to be using to deserialize the messages from the topics. So instead of talk, let's just do it. In here, we want to create a new package, com.example.LeetJourney.bookingservice.event. And in here, we want to create a new class called booking event. And the content of this class is going to be exactly the same as the one in our booking service, in our producer. So let me just copy that. So I hope this was clear. We had to recreate this tree because in our listener, we want to reuse the same class that our producer used. There are various ways, more elegant ways to handle this, such as a shared client between the two classes, or have like a jar where you can have these kind of objects that are shared between two services. In this case, this is the easiest way for us to do it. Okay, so make sure the rest of the code goes inside this other package, the one specific to order service. We want to create an order using the details from the event we retrieved from the topic. So this is a booking event, and we'll use it to create an order. So we need to create this order class. This is going to be an entity. So let's create a new package called entity. Let's create a new class called order. And this order class, as I said, it's an entity. So let's add the entity annotation, data. Let's create some constructors. Let's create a builder and let's define the table name. So the table name is the one we have created using the DB migration, and it's called order. And if you remember, I told you that this order name, it's a reserved word in SQL. So we want to use backticks to escape this. Make sure to add these if you have the same name as mine. Next thing are the attributes. We can find these attributes inside our DB migration. If we go to inventory service and we go inside the DB migration, create order, these are the attributes we need to add to our order class. We are going to need these ones. So we have an ID. We need to add the ID tag. In the DB, the column is called total, but in our application, I decided to call it total price as it's more readable. And we got a ticket count placed at, make sure this is a timestamp, so add this tag. And then we got our foreign keys. So our entity is now ready. If we go back to our order service, we should be able to import it. Let's call order. So it's not giving me the option to import. We can add it manually. So com.LeetJourney.orderService.entity and order. And the error is gone. And now we want to create this order. So I've added a private method so that the order event method is more readable. Private. We want to return an order object and we want to create an order. We are going to be passing in a booking event and then create an order from the attributes in this booking event. Just want to remind you, this booking event will be retrieved from the Kafka topic called booking. We have our order. Now we want to save it to the MySQL DB. So we need to create an order repository and then we want to save this using JPA. We want to save this order object. So let's create a new package called repository. And in here we want an interface called order repository. We want to extend JPA repository and it's going to be an order class and long is the identifier and we want to tag it as a repository. So if we go back to our order service, we can auto wire this into our order service class. So private order repository, let's import and now let's create the constructor for order service and let's inject this order repository. Okay, so this order has been saved to the DB. Next step is to update our inventory. To update our inventory, we need to do a few things. First is we need to check if inventory service has an endpoint that we can call to update our event inventory. So if we go inside the inventory controller, we can see that these are all GET requests. There is nothing to update. We're going to create a put endpoint that we will use to update the inventory for our event. So let's create it. So it's a put mapping. This looks correct. And we want to update our event capacity. So we're going to be passing two path variables, the event ID and the capacity. This is how many tickets have been booked so that we can subtract them to the current capacity for this specific event. So in inventory service, we are going to create a new method called update event capacity. So if we go in inventory service, let's add it here. So update event capacity, it will accept an event ID, how many tickets have been booked, and simply will first retrieve this event from our DB by event ID. And then we will set the left capacity by taking how many tickets are left and subtracting the numbers we have booked. And then we'll save this to our DB. So actually let's do save and flash, and let's add some logging. Let's say update event capacity for event ID with tickets booked, and this looks good. We need to add a logging, so let's add the tag slf4j. So we've got our endpoint ready in inventory service. It was quite simple and quick because we've got everything in place. Let's go back to order service and let's create a client for inventory service. And we'll be calling an update inventory method inside this client, and we will be passing the event ID and the ticket count. Let's create a new package called client, and let's create a new class called inventory service client. This is a service class. We need to define a value, so we need to add this into our application.properties, the URL we want to query. So if you go to resources, application.properties, let's add that down here. Inventory service is running on port 8080. This is correct. This is the base URL. And in our inventory client, we can now assign this to a string. Next thing we want to do is create the actual method. So response entity as a void. We want to update inventory. We'll pass an event ID and a ticket count. We now want to create the actual call to the inventory service. So we're going to use a REST template. And now we can do REST template.put inventory service URL event plus event ID. Capacity is the ticket count, and we can simply return response entity .ok.build. In the service class, we want to inject the inventory service client inside our constructor. So now we have updated the inventory. Let's add the log. And let's say inventory updated for event, less tickets, the number of tickets we have booked. And we are almost ready. So we've got a slight error there. We need to define few properties. The server.port, order service will be running on port 8082. Let's add our MySQL DB configurations. And we need to add our Kafka configurations. So make sure that these are correct. In the booking service, we had the key serializer. Instead, here we've got a key deserializer, and same as the value, it's a string deserializer in this case. For the value, we are using a JSON deserializer. In here, we also need to add the JSON type mapping, order event, Kafka listener. We are using this booking event, this class here, and that's the one we want Kafka to use to deserialize our messages. So this is quite important. So this is all we need. We are ready to place our first order. Let's go to inventory service. Just make sure your Docker Compose is running successfully. If not, just do Docker Compose down and then do Docker Compose up. But we already have this running from the previous step. Let's start inventory service. This has started successfully. Let's start booking service. This has also started successfully. And now we want to start our order service. So we need to create a configuration, call it order service. We want to run the main class, apply, okay, and let's run. Hopefully there are no issues. Okay, so looks like this is running correctly. Let's go to MySQL Workbench and let's make sure there are no orders. So there are no orders. Every time we restart our Docker containers, we will need to recreate this Kafka cluster. So that's what I'm doing here. I'm just doing this so we can see what's going on. I have quickly recreated this. We got our topic booking. We've got 0 messages. Let's just do a GET request using Postman to our inventory service for event 1. And let's see how many tickets are left. We've got a capacity of 39,900. Let's place a booking now. So we want to place a booking for user ID 1 to event ID 1 and a ticket count of 10. So let's see if this goes through successfully. Let's check our order service logs. So we received an order event. Inventory got updated. Let's verify that the order has been placed in our DB. So we've got our order. We've got the total price 100 and we ordered 10 tickets. If we go back to Postman, let's do a GET on the event to see if this capacity has been updated. Capacity was updated. Let's place a couple more orders. So let's do 30 for example. Let's send a couple of orders. Let's see if the capacity decreases. It has decreased. And if we go in our MySQL workbench, we can see all these orders have been placed. So what is happening here is we are publishing messages on this topic. These were our messages and these are being picked up by the consumers. So order service has created a consumer with group ID named order service. And this is the one that has been picking up our messages from this topic. So I hope this part was clear. So this is what we have done so far. Booking service has placed a message on this topic. So it shouldn't be a queue. It's a topic really because we're using Kafka. Then order service as the consumer of this topic has been picking up messages from here. It gets the message, it creates an order and saves the order in MySQL DB. After placing the order, it does a synchronous call to inventory service and the inventory service updates the inventory for our event inside our main database. So we've got our main flow, our main logic. The next thing we want to do is look at this API gateway.